Good morning, HVAC team. So today we're moving on to chapter 33, which is about electrical measuring and testing instruments. So let's go ahead and get started. So objectives are list the major types of electrical test instruments and explain how they are used. Explain the difference between weighted average meters and true RMS meters and RMS meters. Identify the CAT rating on meters and explain its importance. Describe the difference between analog and digital meters. Demonstrate how voltmeters, ohm meters, and ammeters are used. Take measurements on a de-energized circuit with a test meter. So category ratings, CAT 1, CAT 2, CAT 3. So CAT 1 is required for, and these are the ratings for your meters. So CAT 1 is required for use on low energy equipment such as protected electronic circuits and on high voltage, low energy sources from a high winding resistance transformer. A typical example of that would be a photocopier machine. And then a CAT 2 meter is required for single phase receptacle connected loads, such as appliances, portable tools, or other household type loads. The outlet should be located at least 30 feet from a CAT 3 source. And then CAT 3 is the kind that we use in the field mostly, is required for distribution circuits, such as three-phase bus and feeder circuits, load centers, and distribution panels. These test meters are also used for permanently installed loads such as three-phase motors, large commercial lighting systems, and heavy appliance outlets with support connections for the service entrance. So I have my meter with me right here, and I use Fieldpiece. That's my particular brand of choice, but if you see down here at the bottom, it says CAT 3 600 volts. So that's the rating on my meter, and this is the typical meter in our trade. Back up a little bit. So category numbers range from CAT 1 to CAT 4. A higher CAT number is used for higher voltages and energy transients. A test meter designed to a CAT 3 standard can resist much higher energy transients than one designed to CAT 2 standards. There are also voltage ratings within a category. So for example, a CAT 3 1000 volt test meter has superior protection when compared to a CAT 3 600 volt test meter. So they're both CAT 3, but one's a 1000 volt rating and the other one's 600. What I have is a 600, which is good enough. You can see on this example here, they have two ways you can hook it up. So your common is your common, but you can hook up to the you can hook up for a CAT 2 or a CAT 3. Oh, I'm sorry, no. Over here, you can hook up here for CAT 2 or here for CAT 3. Mine's just a CAT 3 all the time. Independent testing laboratories, meters, selection, and test leads. Typical recognized agencies include the Underwriters Laboratories, CSA, and TUV. The test leads for the meter are just as important as the meter ratings. They should be certified to a category and voltage the same or higher than the meter. So I just showed you my meter, and these are my test leads. I unplugged them so you can see where it said the actual CAT rating on my meter. I'm gonna go ahead and plug them back up. Pretty obvious, but just, so you know, that's where my meters are plugged up. And so these are my meter leads. And then on the side, it's real hard to see on camera, but the rating is on the side here on the label. So on this one, you can see it says CAT 3 right there above my finger, CAT 3. So it's on the side. These are actually mismatched because I'll be breaking stuff, but this one also has it. So right here on the side of my lead, it says It says Cat 3 somewhere on there. I can't see anymore. Anyway, so you want to make sure that your leads match up with your meter. Test leads, alligator clips. I like those, they come in handy. So alligator clips are handy in freeing up your hands from holding the test leads, which allows you more freedom to set the meter for the proper reading. So the alligator clips, I like those because there are times where you want to check, like for instance, like you want to check the startup voltage in comparison to the running volts, because sometimes they, starts up a little high or low. So when you're trying to check something like that, as soon as you turn the system on, then you got to get your leads in place, and sometimes you can miss that startup voltage. So with the convenience of having the alligator clamps, you can clamp those on while the system is de-energized, get your meter set where you want it, and then flip it on, and you can watch and see your startup volts. So alligator clamps come in handy. Also, they're a little bit safer. Usually when you're hopscotching, you want your regular leads because you want the freedom to move from one point to the next. But the alligator clamps have their uses too. I don't have mine. Well, I got short ones. I don't know what happened to my longer ones. I got short ones that I can connect, but then I would have to hold the meter super close. So what I do when in a moment where I feel like I need alligator clamps, I just pull out my jumpers. And I'll connect one end of my jumper to my lead, and then the other end to the circuit, and then the same on my other lead. And then and that way I can have, my alligator clamp set up. That's my little way of rigging it up. Yeah, you got to get creative when you're out there. That's something that you will all learn very shortly. So analog meters. Analog meters are seldom used today because digital meters are superior in almost every way. Analog meters have a mechanical needle that swings across the dial to a point over a scale. The meter reading is taken by looking directly at the face of the meter dial and comparing the needle location to the appropriate scale. Some technicians prefer this type of display to and consider it superior to a digital meter. And that's usually the older guys, and that to me is a bunch of bull. The old stuff is accurate and it works, but the problem that I find with the old, well, first of all, I've never owned one. I'm not that, I ain't that old. So, but I have seen them, I have used them, and the problem is the needle never stops. They kind of bounce around constantly, and then you have to kind of pick an average. So if it's bouncing between 8 and 12, then you kind of just go with 10. So digital meters, they just pick an average for you and throw it at you. So you just see whatever's on the screen, you go with that. It takes the guesswork out of it. Because especially on those Magnehelic manometers, some old school analog ones, that thing will just constantly bounce. And it to me, it's a little annoying. I like to just get a solid number and call it a day. Digital meters. Some digital meters offer both types of display. They incorporate an analog sliding scale that appears across the digital meter face so that it is possible for the technician to have both the digital number and an analog reference. Not necessary for me, but it's out there. Today, the requirement to carry all of these single-use meters is no longer necessary. Multimeters will measure voltage, current, and resistance all with one instrument. Multimeters designed specifically for HVAC applications often provide additional measurements such as readings for capacitance, temperature, frequency, and power. So that's what I got here. So it looks like here is I think this is a megometer. And then over here you have measuring room temperature. Oh no, that's a multimeter. So okay, so these I think these are both multimeters, but there are straight voltmeters, and then you got voltage testers. You have just straight amp meters, or when before all these advancements in technology, there was literally a tool for each thing, and now we have multimeters that do a bunch of stuff. So if you can see right here, and your meters all do it too. Excuse me, they might look a little different, but yeah, so this one has the can read temperature here. You got DC volts, AC volts, everything. You can read your amps. You put it here for put it here for amps. It reads continuity, everything, capacitance for your for your capacitors. So, you know, multimeters are just the way to go. You all get one in your kit. It looks different. It's a different brand, but it does all the same stuff. Also, let me go ahead and turn it on. So it's a digital screen here. Turn the light on so you can see, you know, there's no needle and all that. You don't have to worry about the needle bouncing around and not knowing exactly what the measurement is. So that's the way to go. That's the pretty much the industry standard now. So you'll all be real familiar with your digital meters by the time you finish the course. And analog is old news. So meter range, resolution, and accuracy. The range tells you how long and how high of a reading the meter will provide for each function that the meter can perform. Many meters today have an auto ranging function. I believe the meters that you guys have in class, or at least the ones that I've seen, because I think they changed them. The people, older classes had different meters, but the ones you guys got, it has a range function on there. I don't like that. I like this one just has an auto range. I don't have to really focus on all that. I just pull it out and I just get right to what I'm trying to do. So testers. So over here you have a non-contact voltage tester. So it says this type of tester does not have test leads. The tester does not touch the conductor, but it is placed close or within proximity to it. The tester will light up if voltage is present. They are good for a first test, sorry, but should always be followed up with a direct contact meter. So they're good to let you know if there's voltage present, but they're not measuring the voltage. So you won't know exactly what it is. I want to plug something up really quick and show you. I'm gonna plug my charger in real quick. So the non-contact voltage testers, you can see a small picture of it right here. And a lot of guys like them. They're small, they fit in your pocket like a large pen or a marker, and you can just pull them out, and they call them receptacle testers. And you just put it up to the receptacle to see if it's live or dead. So my meter actually does that. So rather than having a separate tool just to do that, I could just pull out my same meter, and what I'll do is I'll set it to NCV. So that right there, that NCV section stands for non-contact voltage detection. So now that is set to NVC. If you look at the tip right here, you see those little lightning bolts? That's just letting you know that this is my voltage tester. So I could just point this tip at a receptacle and it'll tell me if it's hot. So I'm gonna point it at my charger and see if it'll beep for me. Take it away, no beep. Put it towards the beep. Matter of fact, that's too far. Well, you couldn't see it, but you can hear it. So once I point this towards my charger, it's gonna beep. So that's the no contact voltage tester. Now I know there's voltage present. Now if I want to see how much volts, I could go ahead and set it to my VAC, which is voltage, and then also alternating current. And then I'll pull out my meter leads, put it across the load, test it, see what I got. So some people like to have the non-contact voltage tester handy just in their pocket rather than going for their meter, which is usually in their bag or something, and that's fine. Me personally, I just pull out my meter. So there are two general types of voltage testers, solenoid-based and electronic. Both types have test leads that must come in direct contact with the conductors. Solenoid-based testers that vibrate and light up are seldom used anymore. Some multimeters have now built in a voltage testing function that allows you to start with a non-contact proximity test and then move to a contact test with the same instrument. So that's kind of what I just demonstrated. That is what I just demonstrated. My meter has a built-in non-contact voltage detector. Measuring voltage on a live circuit. So probe extenders keep your hands further away from the conductors. Test probes with a minimum amount of exposure or exposed metal at the probe tip, such as 0.012 inches metal tip probes. So they're basically talking about the length of the tip of the probe, this part here. And then voltmeters are connected in parallel with the load to read voltage drop or potential difference. In testing a circuit for proper voltage, one lead goes on each side of the load. Well, let me just backtrack really quick. So there, the reason why they specify the length here, and they have protectors that you can put over this, and it only exposes the very tip rather than this entire piece, and that protects you from making a mistake, because you can accidentally short out a circuit if you're not careful with all this exposed metal on your probe. So that's just something to watch out for. Measuring voltage on a live circuit. Read the instruction manual for your meter, for the meter that you're using. Some meters have function buttons in addition to the selector dial. How to measure voltage. An example of use for a voltage or voltmeter is to determine if a hidden switch is open or closed. This is helpful in troubleshooting. If there's a power, or if there is power in the circuit and the leads of the voltmeter are placed on each side of the switch, a voltage reading indicates the switch is open, and a 0 reading indicates the switch is closed, if there's no other switches in the circuit. So basically, if this switch here, right here, this switch is closed, so you're getting a 0 voltage reading. And then over here, the switch is open, so you are getting a voltage reading. So that's an accurate way of checking to see if your switch is open. But an easier way, or the way I do it, is I just do a continuity test. On my meter, when you do have continuity, it'll beep. So as soon as I touch these two leads together, you get a beep. So I would just place one lead here, and wait for, if I don't get a beep, then I know my circuit is open. Over here, this one is closed. So if I put my lead here and my lead here, I'm guaranteed to get a beep letting me know that my switch is closed. So whenever I'm specifically checking switches, I just do my continuity test and look for the beep. An example of that would be your limit switches and rollout switches that are in your furnace. Your furnace is off and you're trying to figure out what happened, and you suspect that the limit switch is open. Then you can put one lead on each side of that switch and wait for the beep. If you don't get a beep, then you know that the switch is open. Then you go ahead and investigate why. Ammeters. The clamp-on ammeter is one of the most useful of the electric meters for HVAC technicians. It is used to measure current flow through a single wire by enclosing the wire within the jaws of the instrument. Exhibit A. That would be the amp clamp. Sorry. So inline instruments that only measure amperage are not commonly used. Instead, multimeters are the most common electrical measuring instruments for HVAC work because they are able to do so much more. Some multimeters have a removable clamp-on available as an accessory that may be used with the meter. When using a multimeter as an inline meter, the proper location for its connections in a circuit is shown in figure 3522. Note that it is connected in series with the circuit being tested. In DC circuits, verify the correct polarity of the amp meter used before energizing the circuit. Never connect an amp meter across a load. It will destroy the line current, and as there is no load to limit it. I personally have never used the inline amp meter. I've always, since I started in the trade, I always had a clamp, amp clamp or a clamp on ammeter. And you simply put the wire that you're measuring through there. Now you want to get only the one you want to measure. You don't want something like that where you got two wires going through there. You just want that one. And the way it's measuring the current is because when there's voltage applied to a conductor, it creates a magnetic field. This is measuring that magnetic field and then converting it into an amperage reading. So that's how the amp meters work. Ohm meters. Ohm meters measure the electrical resistance and can be used to check a circuit for continuity. Multimeters will have this function, and so will some of the clamp-on ammeters. Continuity means there is a complete electrical path. When the test leads are touching, when the test leads are touching each other, there is a complete electrical path. The meter is measuring the resistance of the wires of the test leads at 0.18 ohms. When the test leads are separate, there is an infinite resistance as indicated in the meter reading OL. So whenever you see OL, then you know the circuit is open. Whenever you get an actual resistance reading, then you know you're dealing with a complete circuit or a closed circuit. So you can see right here that the leads are touching, you're getting a resistance reading. Over here, the leads are not touching, you're getting an OL. And that would be the same if you were checking an actual circuit. The leads right here are touching each other, but if you were putting each lead at a different point in a circuit, but that circuit had a complete path, then it would still give you a resistance reading. If you put one lead, each of these leads on different points of a circuit, but that circuit is open at some point, then you'll get the OL reading. Ohm meters. In the first figure, the meter is measuring the resistance through a wire in a circuit, and it registers 0. This indicates maximum current flow or zero resistance. This is the measurement of a short circuit or a good set of closed contacts. So if you check in a de-energized circuit and to see if it's open or closed, then this is what you get. In the second figure, the meter is measuring the resistance of a coil, which has a measurable resistance that is read on the meter. So that's over here, they're checking the coil here, and that is the resistance on that coil. And then in the third figure, the meter is measuring the resistance of an open circuit, which is read on the meter as infinity. Infinity means that the resistance is so large that it cannot be measured. It means that at this point, there is a lack of continuity or no current flow, or no current could flow. So that's what's happening over here. Nothing, because we have an open circuit. As you can see right here, these contacts are not touching, open circuit. So these contacts are closed, these contacts are open. Over here, you're getting a reading. Over here, you're getting infinity or OL if it were digital. So care must be taken to prevent errors in reading resistance when two or more circuits are connected in parallel, the meter in the illustration is actually reading the combined resistance of two parallel circuits, HTR1 in the blower, or heater 1 in the blower. To read only one resistance, one side of the component being tested is disconnected. So as you can see here, you have everything is still connected, and which is why your resistance is really the resistance of both these circuits. Over here, they've disconnected it at this point. So now you're only getting a resistance reading on just heater 1. Multimeters and megameters. So one caution needs to be followed. Do not use an ohm meter to test a solid state circuit unless the manufacturer specifically allows it. The internal battery voltage of the ohm meter can damage an integrated circuit chip. So you can see here in this little illustration, they got their 2 meter leads here testing this little chip. That is not something that I have ever attempted in the field. A bad board is a bad board. I change out the whole board. I don't get into electronics to that extent. That is not a typical HVAC task. We'll diagnose the board and just swap out the whole board. So some ohm meters, often referred to as megers, must be able to read resistance of tens of millions of ohms. So here's a mega right here. I don't own one of these, but I kind of want to get one because it's a clear, easy way. Like, for example, like if you're testing a compressor, it's a clear, easy way to show the customer the health of their compressor. Because sometimes people get the idea that, oh, well, you know, it turned on, so it must be okay. But this will let you know right here that if your compressor is at the end of its functional life, you can connect your leads to your compressor terminals, and then the megger, it'll light up. And so here in the green area is good, where it says good, and then up here in the yellow area it says caution, and then up here in the red it says bad. So if the lights light up and it stays within the green range, then you know your compressor is good. If it gets into this caution range, that's the point where I want to show the customer, like, yeah, your compressor is operating, but it's not performing, and it's at the end of its functional life. And it, you know, and the meter is telling them right there, like, you know, be warned that your compressor is at the end of its life. And then bad, usually you'll know if it gets to that point because it won't work. But so that's a megameter or a megger. It's a good tool to have, but you can always ohm out a compressor with your multimeter as well. You don't necessarily have to have a megger, but a megger reads small, you know, it reads smaller measurements. So meggers. For testing an electric motor, the power supply must first be disconnected and the motor isolated from the circuit. Then one test lead is attached to one phase of the motor, while the other test lead is attached to ground, usually with an alligator clip. Megger readings. The ground connection is often the motor housing. When attaching the lead to ground, make sure to scrape any paint until bare metal is showing to ensure a good connection. A high megger reading would indicate that the motor winding and insulation are good. A low megger reading would indicate a shorted motor winding. So over here, you got that low reading, shorted motor. Over here, much higher reading, windings are good. Capacitance meters. Capacitance meters measure in microfarads. Most capacitors are within the range from nanofarads to microfarads. 1 microfarad is equal to 1/1,000,000th of a farad. Before testing a high voltage capacitor, always begin by properly discharging the capacitor first. The meter measures capacitance by charging the capacitor with a known current and measuring the resulting time of charging period. From this, the capacitance is then calculated by the meter. The leads will have a residual capacitance. The known capacitance of the circuit is shown in 4 microfarads, as both 2 microfarad switches are in the closed position. So I got my capacitor here again. I've shown it before, but just a little bit of review. So this is a typical run capacitor. If you look at it close on that label, you'll see right here, 7.5 with that weird little UF looking logo. That's the microfarad symbol. 7.5 microfarads is what this capacitor is supposed to be putting out. So like they said, the first thing you want to do is discharge it. So you'll just take a little screwdriver, short it out by touching these terminals to these terminals, short that out, and then you can go ahead and test it. And you'll put your multimeter on this function, because as you can see right here, you've got MFD for microfarads. So that's letting you know that this is the function that we're going to use to check our capacitor. So then we just take our 2 leads, put one here and one here, and then we should be getting 7.5. Oh, however, we're not going to get 7.5 because this is the bad capacitor from my other video. So right now, I'm getting 0. If you look, it's kind of, I don't know how easily or difficult it is to tell, but this surface down here at the top is bubbled out. It's convexed. So that's always a bad sign. When you see that on the capacitor, you know you got a bad capacitor. So it should have read 7.5 microfarads. It read nothing because it is a bad capacitor. But yeah, that's how you want to check it. You want to discharge it first because they hold juice, and then you don't want to get hit. I got hit before. I was using some pliers to try to pull the wire or the wires off of the terminals, and it was on there pretty tight. So I kept pulling and pulling, and I tried to get a better grip. So I reached in, and my hands, without realizing it, went from the insulated part of my handle to the metal, and I touched it, and boom, and I got zapped. And it freaked me out. It wasn't even that bad, in retrospect, but at the time it freaked me out because that was my first experience with any kind of electric shock, and it took me like 20 minutes to get back to work. I just sat there scared, like, damn, I don't want to touch nothing. Like, and so anyway, you just got to discharge them because they pack a little bit of juice, and they can hit you. So capacitance meters. The meter measures the circuit at 4.198 microfarads due to the capacitance of the meter leads as shown in figure 3538. Most meters will allow for the subtraction of the residual capacitance of the meter and leads. The meter must be connected for the proper polarity of the capacitor. Now they're talking about power. So now we're talking about watt meters. So power that is measured by simply multiplying the current by the voltage is called apparent power. However, this is not a true indication of power. To mathematically calculate power in watts using the measured volts and amps, it is necessary to know the power factor. Watt meters incorporated the power factor to read true power. So I also got my little watt meter. So this is what I use when I'm checking like the performance of a furnace or something. I would how you would do that is you would unplug the furnace from the wall, plug your watt meter in its place, boom, plug that into the wall, and then you would then plug that furnace back up into the watt meter itself, and then you where's my oh it's not plugged in. Then you would hit watts, your watt function, and then it'll let you know the watts that the furnace is pulling. So that comes in handy too. And these are fairly cheap. I think I got this at possibly Harbor Freight. You don't got to spend a bunch on your watt meter. I wouldn't get a multimeter from Harbor Freight though. This is for me. It's always Field-Peace. I love Field-Peace. Their stuff works good, and they got the lifetime warranty that I love. So yeah, that's my preference. So anyways, in summary, always use the highest scale on the meter first and then work down to the appropriate scale. Always check the function of a meter before using it. When using a clamp-on ammeter, be sure the jaws are around only one wire. Always have an extra set of meter fuses and replacement batteries on hand. Never use an ohm meter in a circuit that is powered. So that is it for Unit 33. Review questions are on FlexiQuiz. So study up, hit the book real hard, study, and I'll be catching up with you guys shortly. I got a few people who needs to come to campus for testing, so we're gonna get that going. And but other than that, I hope everybody is staying motivated, staying safe, and staying healthy, and continue to study. This whole thing will be over. We'll be back in the classroom soon as possible, and when that happens, we're just gonna pick up where we left off. So don't fall behind. Study hard. See y'all on the next one.